Hello, welcome to Let's Talk. I'm Bill Moore, the CEO of Atmosoft. I'm also the solutions architect. Today, I want to talk about some. This week, we're doing a push on just kind of educating people on some security around software development. Today, I want to talk about a software development architecture pattern called in-tier architecture, and what that is, and what are some of the security benefits of considering it. It's also referred to as a layered architecture, and what it is basically you're dividing your system up into three separate pieces. You're going to have your UI UX, your business layer, and your data access layer. So when it first came out, it was referred to as three-tiered architecture because we just had those three levels. And as we evolved and expanded our understanding of and our best practices for software development, we moved to kind of an in-tier. So you could have as many layers as you want, but the primary pieces you're going to see in most of these are usually UI, data access, that would be a two-tiered architecture, or UI, business layer, data access, that would be three-tiered. And you could divide these up into as many tiers as you want. Another one would be UI, business layer, repository layer, data access layer. I think that adds a level of complexity, but you can kind of see where we're going with that. So in particular, this week, due to some things that happened to me last week, I've been thinking a lot about how I can create more secure code, and how we as an industry can kind of prevent some of these data leaks that have been happening. I was unfortunately involved in one. Actually, I was involved in two last week. So I want to talk about that. I really like this pattern, and this particular architecture is kind of one of my go-tos. It's kind of where I start. And believe it or not, you can have a monolith that is in tier. You could have it all running on the same machine. You can break it out into multiple machines. I could have a database over here. I could have my UI hosted on the web server over here, and my business layer hosted on an entirely different machine, and they're communicating via an API. You can kind of break these components out into different pieces. I think it gives you a good modular architecture for your application. And I think the pattern works really well and scales really well. Again, you can do in tier in a monolith, and you can do in tier on separate machines with microservice interfaces. You can make this as complicated or simple as you would like. So getting into some of the benefits that I really like about this particular architecture and how it mainly focuses on security. The first one I want to talk about is separations of concern. So this is a good programming practice in general. When you're designing your classes and your components and your functions, really you want to try to get everything down to it's doing one thing. So if I have a class that is for automobiles, that class is specific to automobiles, and it does all the work around automobiles. Has an engine function. There's a Ford Ranger subclass, and you keep moving around that. But what we mean here in particular, separation is the current concerns, is the UI worries about the UI, the business layer worries about the business logic, and then the data access layer worries about retrieving and saving things to the database. So what we get here with these separations of concerns is we have a UI that is built that is handling all the UI logic. And as I move down the layers, I'm transferring, kind of like workflow. I'm kind of working down these different processes, and I'm transferring through these different silos, and they're each concerned just about their particular work items. So the UI is concerned about user input validation, communicating, exchanging data with the server, displaying the web page for the user. The middle layer, or the business layer, which can be an API, or when you're starting out, if you're doing more of a monolithic architecture, it could just be as simple as this is in .NET terms. This is in another assembly. It's its own DLL, which is useful for more things, or it's useful for to be in a DLL, because then you can include it. You can include the business logic in different applications in your enterprise. For example, I often like to use this pattern, and I'll have my UI doing all the UI stuff, and then I'll have the business logic layer will be a DLL, and that will be into the web application. Right now, it's kind of the way I'm describing it's kind of in a monolithic pattern. And so, but at a later date, if I want to pull out my business logic layer, I can grab that DLL, stick it up on a web server, and wrap an API around it. And then I expose the DLL through the API layer, and now my business logic is hosted, and it has an interface that can interact with different applications, different customers, that kind of thing. And same with the data access layer too. You can host that. You can wrap it around with an API layer that just calls into your data access layer, and you can provide access to your data layer. I'm not sure 100% you want to do that, but you can provide direct access to your data layer, and then you can set up the communications between the UI web server communicates via API to the business logic layer, which communicates API to the data access layer, and you can move forward with that pattern. You get a lot of great you get a lot of great security here because all your layers are isolated. So I have my UI, it's just doing UI things. It's not worried about the business logic. Its job is to display data and collect data. And then my business logic's in one place, and my data access layer is in one place. This goes into the next point, which is defense in depth. So what defense in depth is because we have these isolated layers, each layer is you can think about it like a wall around your application, right? So I have my UI, I have my business layer, I have my data access layer, and then in the center I have my application logic. So it requires the intruder, or if someone's trying to hack your application, it requires them to get through 3 separate pieces before they basically own the application or own the server. So the other thing that you want to take into consideration here is the concept of least privilege. So we talked about defense in depth, and we talked about separation of concerns. Depending on how your in-tiered architecture is deployed, you want to make sure that all your components are running with the least privileges possible. Back in the day when we first started, and I'm guilty of this too, I don't do this anymore, but we would deploy an application. When we would run into a scenario that looked like it was permission related, we would give the application admin rights, and then the permission problems would go away. I think in today's environment, that is not a healthy way to escalate your application. So you should deploy your application and then tweak permissions as needed. Say you need to write to a directory outside of www-root in Windows and IIS, and you need access there. You should explicitly grant permissions to the application pool so that it's able to access the resources it needs on the machine. But again, using the least privileged model, which means I'm not going to give it admin privileges. I'm just going to give that particular user that is running the application pool permission to work in a given directory or whatever types of permissions I may need for the application to function correctly. At every layer, so the next one is called a data abstraction. So every layer we're putting in gates that prevent us from getting invalid input. So on the UI, we're sanitizing the data that's coming from the UI to the server, and we're checking data, and we're doing validation. We're making sure we're getting expected inputs. That's a very good practice to do. However, so a lot of times what will happen is you'll call an API from the front end, you'll pass it some data, and then you start getting into the business logic side of your application, and you don't redo the checks. And it's very important that you need to do the validation checks at every layer. So if I validate it on the UI, for example, I can go in the browser and I can modify settings. I can modify cookies. I can modify posted values. I could hit you with Postman and make it look like it's a form input and pass you unexpected values in an attempt to break your application. So it's critical that on the business layer side that we're also doing validation over there. We're checking again. So same thing happens when you go from your business logic to your data access layer. I'm going to start storing some data into a database, or however you're storing it in a file. Mostly it's going to be a database, so data access. So we come into the data access layer, and we're going to sanitize again. right? Because we just want to make sure that each point that we're checking to make sure that the data that is being passed to us is valid data for us to take action on. We don't want to inadvertently expose data, and we don't want to cause a problem in the system. The other benefit of the interior architecture is auditing and monitoring. I think personally, you get better control as you pass through the layers. So maybe on the UI, I'm logging and adding auditing on user actions that are being sent to the server. The user requested to look at invoice number 1, and I'm logging that, saying user B more wanted to access invoice 1. He had permissions. We displayed it. So we're going to have some UI logging there. We could have the logging in the browser. We could be pushing a log via API up to the server, so we could track the user's state as they move through the application. Then the business logic, I'm going to be doing the same thing. This method was called. I did this lookup. This user requested this value, and we're basically providing tracing through the layers. So I like consolidated logging. So typically, I would have some type of logging service that I'd be pushing log messages to, with some type of session, some type of session ID that I would be able to track, so I could see the actions of that particular user throughout their whole entire session. It's good for debugging, and it's also good for security. If you are deploying the application, actually both in monolith or if we're doing if we have the application on separate machines, deployment and updating becomes a little bit easier. I mean, it depends on your particular scenario, but it can be easier. For example, I have a web application. I didn't make any changes. So we're going to do web application, and the business layer and the data access layer are separate DLLs that are bundled in with the web application, deployed with the web application. So we're still in tiered because we have logical separation between our tiers, but we don't have physical separation. So we're not hosting on different machines. We're kind of in monolith. We're actually, we should say we're in modular monolith. So what's going to happen here is when I do the deployment, if I don't have any UI UX changes, I can leave that alone, and I can just deploy the 1 or 2 or more. You may have multiple business layer, or you may have multiple DLLs or multiple assemblies supporting your business applications. Maybe you break up those by domain. There's different ways to do this, and they're all valid. So, but if I just need to update the business logic layer, say we found a bug, which not in my code, but I'm kidding. So we found a bug and we need to update production. I don't need to update the whole entire website. I can just basically replace an assembly and then be good to go. Same thing with the data access layer. So you can do targeted deployments to address bugs without having to do a full deployment of the entire application. If you take the next one I want to talk about is access control. So you can set up access control differently per layer. So it gives us a little bit more control on fine tuning what exactly the user is able to do on the UI UX side, what resources they're able to get to, where they can navigate on the site, what actions can they take on a particular page. That can all be controlled, in the UI. That can be controlled with the business layer, and same thing on the business layer and the data access layer. We can tune the individual control points based on the layer of the application the user is currently in. So that's kind of a high level overview of in-tiered architecture, which again, it's kind of one of my favorite patterns. I like to have a good separation of concerns. I like the reusability of having a separate assembly or a separate library for my business layer and my data access layer. And if you combine that with interfaces, you can change the functionality of your application. For example, let's just say I have one assembly that's specific to my application running against SQL Server. So I can deploy that assembly, and all my data access is going to SQL Server. And if at some point later on, I have an interface defined there at some point later on, if I decide that I want my application to write to a NoSQL database, Cosmo DB, of one of those type of data stores, then I can replace the DLL. And as long as the interface matches, I can replace the DLL and I can change where I'm storing my data. You could even change it to, I don't know why you'd want to do this, but if you want to go to file access and you're saving everything to text files, you could even change out your data access layer to write to flat files if you want to. I mean, sky's the limit on what you can do there. So it's kind of good, and it's kind of a good idea to think about in terms of when I'm designing my application. The UI does the UI. The business layer is where all of your business logic is stored. And I think that's a great separation there, because a lot of times you'll see business logic kind of weaved throughout the different layers of the application. And that can start causing you problems, especially when you do an update or you go for an upgrade, or maybe you're doing a new greenfield development for your application. And you need to consider that, if I'm replacing functionality, or if I'm using something like the Strangler Fig pattern to, slowly migrate my users over to a new version of the application, I never want to miss some business logic that the application needs to function correctly. So I want to take that into consideration. And when we have all of our logic stored in a separate assembly, we can look at that and say, oh, when someone buys a widget, we have to do X, Y, Z, and that's in the code, right? But it's all in the same place. So we can look at that assembly and we can say, okay, if I'm going to update this to a new version of the application, maybe we're going from .NET to Java, maybe .NET to Python, or Java to Python. We can look at those assemblies, and we can look at those jars, and we can go in and we can figure out exactly where we want, what changes we need to make, and what our rules are. Because a lot of times rules will evolve in the application in organic fashion, meaning we deployed an application, we thought we were good, everything was running fine, and a user calls in and they said, I'm not able to save this particular type of warranty, or I'm not able to order this particular item. And then we can go in and we can make code adjustments, and we're basically adding a business rule that allows that particular user or that particular group or something else to take some action on the site. That becomes a kind of a soft business rule. It's kind of an exception where normally the application flow is this way, and now we're going to deviate from that, and then that becomes in the code, and that becomes a soft business rules. And those are the ones that you don't want to miss. I have applications I've worked on where there's a lot of conditional processing based on what sales has promised to the end user. So there could be something that the application didn't do that for this particular user we do want it to do. We want a separate report screen, or we want to show them data in a different way. So we added in another screen, and then we added in another service, and that's pulling data and doing this thing, but it's very user specific. So when we get those rules that are spread throughout the system, it becomes much harder to get an idea when we want to do a major update or upgrade path. It's a lot harder to get to the full understanding of exactly everything the application is doing. So that, in a nutshell, is some of the security benefits of in-tier architecture, and it's definitely a pattern. I think everyone should if you're not aware of it, I think you should take a look at it. I think it fits well in modular monolith. It can kind of fit well in the microservices pattern. So it's something to consider. And then there's some security benefits around laying out your application with this type of architecture. There's some other benefits too. Don't get me wrong, but we're focused on security this week. So we'll say that the security is kind of the point that we're trying to highlight with this particular architectural pattern. So I hope everyone has a great day. I will see you all tomorrow, and look forward to talking to you more about securing your code. Have a great one.